This is a trigonometric word problem. After a severe storm, three sisters, April, May, and June, stood on their front porch and noticed that the tree in their front yard was leaning 3 degrees from vertical toward the house. From the porch, which is 96 feet away from the base of the tree, they noticed that the angle of elevation to the top of the tree was 31 degrees. Approximate the height of the tree. Round your answer to 2 decimal places. The goal of almost all word problems is to formulate an equation in order to solve it. And with the trigonometric word problems, the first step is usually to draw a triangle. So we will use our whiteboard tools here to sketch the information in the word problem. The tree is no longer vertical. It's leaning 3 degrees, and we just need to approximate that with a line that is slightly tilted. And from the porch, when they look to the top of the tree, the angle is 31 degrees. So we will add that information here, 31 degrees for this angle. This angle, well, we know this is tilted 3 degrees from vertical. 90 degrees minus 3 degrees is 87 degrees. And the distance from this porch to the base of the tree is 96 feet. Now, if the tree were vertical, we could use the tangent of 31 degrees to determine the height. But now that it's tilted, we need to find this distance of this side of the triangle. How can we do that? Well, we have some other tools besides the trigonometric identities, the law of cosines and the law of sines. Which law should we use for this problem? Well, the law of cosines we typically use when we only have one angle and 2 sides. But we've got 2 angles. And so let's try to use the law of sines. We'll use this ratio of A over the sine of A. Is that distance A over the angle, sine of the angle A, and distance B over the sine of the angle B. Now, the first thing we'll have to do in this equation to determine this ratio of the length of the tree divided by the sine of 31 degrees is calculate this third angle. So we will add 31 plus 87 degrees, which is 118 degrees, and subtract that from 180 degrees, which is the total number of degrees in any triangle. That's going to give us 62 degrees. So now we have this angle. And we can complete our equation. This 96 feet is going to be divided by the sine of 62 degrees. And we do that with our calculator. It's going to equal 55.99 feet. 0.998 feet. Now, is that our answer? What did they ask for? Approximate the height of the tree. Well, that was the height of the tree before the storm. It's the length of the tree, but because the tree is tilted, the height is technically the top of the tree to the distance from the top of the tree to the ground. And in that case, we need another triangle that I'm sketching here with an angle of 3 degrees. When we know this one side, 55.9, so if we want to get the height, we'll call this H, and we know this angle is 3 degrees. We know this distance is 55.99, basically 56 feet. And so what would our equation be for that? Would just be the cosine of 3 degrees is going to equal adjacent over hypotenuse, which is that height, over 55.998. So what we do is use our calculator to get the cosine of 3 degrees is 0.998 and multiply it by 55.998, and that's going to give us H equaling 55.921, and they asked us to round to 2 decimals. 0.921 rounds to 55.92 feet. So that is the new height of the tree after the storm.